I'm going to look for RC. In order to find RC, I'm going to find this voltage here, VRC. VRC, watch. This voltage here. In a circuit, all the voltages add up to how much? Source, right? This voltage RC plus CE plus VE has to add up to 12. So therefore, the top voltage VRC, would that be VCC minus VCE minus VE? Total minus the voltage here minus the voltage here gives me the voltage at the top. All the voltages add up to 12. So VCC, I know, 12. VCE, what is VCE? 6. That's my cube. So write down 6. VE, I calculated it, 1.2. What do you get? 4.8 volts. Okay? So now that I know VRC, I can find RC. RC is VRC over IC. Ohm's law. VRC 4.8. IC is IC cubed, which is 6 milliamps. How much? 800. Okay, so there it is, 800. 2 resistors found, 2 more to go. I found RE 200, I found RC 800. How did I find them? I started out with a rule of thumb. Make VE 1/10 of VCC. If I don't do that, I've got 4 unknowns. Okay? So I have to start somewhere. Okay, so that's that. Now, I'm going to find VB. So let's go and find VB. VB is this voltage here. Is it always 0.7 volts higher than VE? Because VE, is it not VB minus 0.7? So VB, I'm working backwards, would be VE plus VBE, which would be 1.2 plus 0.7, or 1.9 volts. Okay? I've said, and we've found V base to emitter is always the PN junction voltage of 0.7. Therefore, the voltage at the base is 0.7 higher than the voltage at the emitter. What's 0.7 higher than 1.2? 1.9. So that's VB. IB, we said on page 2, we've got a number of equations that we can work with. One is that equation that we worked with earlier today, VB over R in base, or the standard equation of IC over HFE. Let me use the IC over HFE calculation. The second one. Do you see on page 2? IB, IC over HFE. IC is my ICQ. And I know that, which is 6 milliamps divided by 200. HFE, what is the transistor that I selected? I measured it with a multimeter, came to 200. What's my answer? 30 microamps. So IB is 30 microamps.
It just needs 100.
I know, we changed it to 200. Why? Because that's more like a typical value of an HFE that we found in the labs. It would be something that's given. It wouldn't have to be given to you. Yeah. It would have to be given in the question. Here it was given to be 100, so we crossed it out and put 200 in it. Okay, now we come to IR2. Where is IR2? This current here. And let me take you to page 2. Everybody go to page 2. Stiff circuit. For a stiff circuit, we talk about the fact that this IR2 has to be greater than 10 times IB. IR2 for a stiff circuit. IR2 has to be greater than 10 times IB. Okay? This is based on all those analysis that I did in Appendix B, if you recall, or Appendix 2. In Appendix 2, go to page 13, everyone. Go to page 13. Let me refresh your memory about the voltage divider circuit and stiff circuits. On page 13, we started out with case 1. V out was 5 volts. Case 2, 3.33 volts. Case 3, RL is 10 times R2, which means that the current is 10 times smaller. And so we came to 4.76. And then look at case 4. We said that instead of 10 times, what if I made it even bigger? What if I made it 20 times? Okay? Then did I get to about 4.9 volts? And so is my current 20 times smaller? So that's what we're saying here.